Hi, everyone, and welcome to another Qt Day Talk. We are about to watch the recorded video, Cross-Compiling Qt Applications with CMake by Burkhard Stubert. So let's go ahead and bring him live really quickly just to present him to you all before the video. Hello there.
Hi.
Hi. Welcome to Qt Day. Yes.
Welcome, and
Great.
hope you like the talk, and next year hopefully in Florence live again. So that
Let's
would be
hope.
lovely.
Yes,
Yep.
fingers crossed. So let me tell you all about Burkhard here. He has been working with Qt ever since version 1.44 back in 1999. So wow, he has developed quite a few embedded and desktop applications with Qt and QML. His major products include infotainment systems for US and European car OEMs, terminals for forage harvesters, sugar beet harvesters, and metal sheet bending machines. And he has worked as an evangelist for Nokia's Qt team and has convinced well-known companies from the automotive, STB, TV, and home appliance industries to use Qt. And he was the first to give QML trainees back in early 2010 when QML was still far away from even just an alpha release. And the business connections from his Nokia times made it easy for him to quit his permanent job 7 years ago and to start working as an independent software consultant. He offers professional services for developing embedded systems, preferably with a QML GUI and Qt or C++ middleware. He has worked and lived in India, England, and Norway, and moved back to his native country, Germany, a couple of years ago. And in his spare time, he is hiking, biking, and skiing through the Bavarian Alps. That's wonderful. So a little bit about today's talk. We want to develop Qt applications for embedded systems in the same way as for desktop PCs. And we can change the source code in Qt Creator, build and run the application. A little but important difference is that we must cross-build the application on an Intel PC for an ARM processor, deploy the executable, libraries, and other files to the embedded system, and run the application on the system, all by pressing Ctrl-R in the Qt Creator. And the starting point for our journey is a Qt SDK custom built with Yocto. And we combine a CMake list text file with the CMake toolchain file from the Qt SDK to build the Qt application on the command line. So depending on Yocto and CMake version, we must repair some bugs in the build environment. We extend the CMake list text file to stage the files that will be deployed to the embedded system via SSH. And all these steps will be grouped into a script that could be used by a CI system. And once things are working on the command line, we configure the Qt Creator to build, deploy, and finally run the Qt application. And configuring Qt Creator with newer Qt Creator and CMake versions is relatively smooth. And with older versions, it gets more and more difficult. And as the integration between Qt Creator and CMake is a bit temperamental in Qt 5, we learn some tricks to tame those quirks. And so finally, in the end, embedded development looks and feels as easy as desktop development. So anything you wanted to add to that introduction?
No, it's perfect. So you should do my talks in the future.
Fantastic, thank you. Fantastic. All right. Well, everyone, stay tuned until the end for a live Q&A with Burkhard here. And I just want to give everyone a gentle reminder that if you do have questions to ask while you're watching the video, next to the room chat, you'll see a question mark icon. That's the Q&A chat. That's not the help button. So please ask your questions there just to keep things organized. So enjoy, and we'll see you after the video. Bye.
my talk about cross-compiling Qt applications with CMake from Qt Creator. On the desktop, we are used to simply edit source files in Qt Creator and then hit the Run button. Qt Creator will do the rest. It will build the application and run it on our development PC. Of course, we want the same one-click process for embedded systems. However, Qt Creator must go through several steps behind the scenes to give us the same simplicity as on the desktop. Let me walk you through these steps. My example system is an internet radio running on a Raspberry Pi. Product management decided that the yellow background behind the station name looks awful. They want a red background. So we go to Qt Creator and change the color from yellow to red. Simple. Then we hit Ctrl R or press the Run button, and Qt Creator will deploy the application to the Raspberry Pi. So actually Qt Creator performs a couple of steps. So it first checks whether there is enough space on the device to copy the application. Then it kills the application that is currently running there, which turns the screen into black. And finally it copies the application to the Raspberry Pi. Then it runs the application. So it sends the command for executing the application to the remote device and starts it there. And now you see the background is red as demanded by product management. Qt Creator shows the messages from the application in the application output pane. In the rest of this talk, I'll show you how to set up Qt Creator to perform all these steps behind the scenes after you hit Ctrl R. My talk is divided into 4 sections. In the first section, I lay out the prerequisites to start our journey. In the second section, we set up an SSH connection between the PC and the device. Qt Creator needs this connection to kill the application on the device, to run the application on the device, or to copy the application from the PC to the device. In the third section, we use a script from meter boot to Qt to define a Qt Creator kit, nearly automatically. We only have to do a little modification and then it works. And in the final section, we define the build, deploy and run settings in Qt Creator. And then finally, we can run the application. Let's get started. At this point of our journey, we have built a Linux image containing Qt 5.15.1 and flashed it to the device. So the image is running fine on the device and the application as well. We have also built a Qt SDK and installed it on the development PC. We need the SDK to cross-compile our application for the device. So if we use Qt under LGPL or GPL, we have to build the Linux image and the SDK ourselves. If we are lucky and have a Qt commercial license, we can just download a pre-built image and install the image on our PC. And while installing this Qt BSP on our PC, the installer also sets up the Qt Creator kit for us. So all the things we will learn in the third section with the Qt Creator setup script is done automatically by Qt Commercial. So using a FOSS version of Qt costs you a little bit more time, and you can trade your time for money if you buy a Qt commercial license. The third prerequisite is a working SSH connection between device and PC. So at this point it's okay if we still have to enter a password when logging into the device. We will later remove that because we don't want Qt Creator to ask us for a password over and over again when we run the application. Finally, we have installed Qt 5.15.1, Qt Creator 4.13.2, the latest at the moment, and CMake 3.15 on the PC. So we can try out our Qt application on the PC first. If that's all fine, then we can deploy to the device. It's important that our CMake version is at least 3.14 and the Qt Creator version is 4.11. That makes the installation and deployment of the application an out-of-the-box experience. If CMake is older than 3.14 or Qt Creator is older than 4.11, then you have to write a Qt Creator deployment file. It's a bit painful, but it's doable. Qt Creator needs an SSH connection to run commands on the device remotely and to copy the application from the PC to the device. We set up the SSH connection by adding our device in Qt Creator. We open the Tools Options Devices dialog, press Add to add a new device, and then we choose the generic Linux device and start the wizard. In the first page of the wizard, we specify the connection. We can enter a name of our choice for the connection name, and I choose Pi3B. Then we enter the host name or the IP address. We find the host name by logging into our device and running the hostname command. So in my case, I got b2qt minus Raspberry Pi 3, and that worked fine. I've seen cases where the hostname doesn't work. In these cases, you should try the hostname .local. So here it would be b2qt minus Raspberry Pi .local. That should normally work then. If that doesn't work either, you fall back to the IP address. And you can get them again by logging into your device, running ifconfig, and then you have the IP address, or you log into your router and get it from there. So there are different ways to get an IP address. And finally, you enter the username, which is needed to log into the device via SSH. If that's filled out, you press Next and reach the page where you can set up public key authentication. If you have set up public key authentication for another device before, then you can simply press the Browse button and browse to the private key you have used before and enter that here. And then you could immediately proceed with deploying the public key. If you haven't set up another device before, then you press the Create New Key Pair button and come to this dialog where you can specify the key algorithm, the key size, and Qt Creator will choose the QTC under ID name for your keys. You press Generate and Save Key Pair, fall back to the previous dialog, and you see the private key file is entered here now. and now it's time to deploy the public key. You see a progress dialog which typically will succeed, and what Qt Creator does here is that it copies the public key to the device. The private key is on your PC anyway, together with the public key actually. And when Qt Creator later logs into the device, it checks the file, the authorized keys file in .ssh, whether it contains a public key it knows about. And so it checks, do I have a private key to the public key from the device? And if so, it's authenticated. So we press close here. So the deploy public key is ticked now, so it's all fine. We press next to reach the summary page, the final page of the wizard, and we press finish now. And Qt Creator performs a couple of tests here to check whether the SSH connection is fine. It checks, for example, for SFTP and rsync, and whether it can probably execute commands over SSH. If you close the wizard, you fall back to the devices dialog, which shows you all the data that you just entered. So you can run a test again. You can show the running processes from the device, so it actually shows the process table from the device. You can again deploy a public key if that failed for some reason, or you can actually open a remote shell into the device. So this is equivalent to typing SSH root at IP address or host name in your Linux terminal and then logging into your device. Setup script performs the heavy lifting in defining the Qt Creator kit. We follow a 4-step procedure to define the kit. The first step is just to close Qt Creator, because I don't know whether we can run the script while Creator is open. I think we would confuse Qt Creator then. The second step is to run the script configure qtcreator.sh. We find the script in the files directory of the MetaBootQt repository, and it's under GPL version 3, so we can use it for building. It's available since around March 2018. Before 2018, we had to do all the things of the script manually. So we had to open Qt Creator, then define a Qt version, a compiler, a CMake version, and then finally put together the kit. And the script, the configure Qt Creator script, does that mostly automatically. Once that script has run successfully, we start Qt Creator, and then in a final step we do a little modification because the kit is a bit incomplete. So this is the call of the configure Qt Creator script. Well, the paths are pretty long, so I defined them up here as variables like project path, SDK path, then the environment setup, script actually, that's the same script as used when setting up an SDK, then the path to the Qt Creator installation, and then finally the name of the kit, which is here AirPi 3 -XXX. And so now the the call to the script becomes a bit more readable. So we call it with 3 arguments. So a config argument that gets the environment setup script, a Qt Creator argument which takes the installation path through Qt Creator, and finally the name. And this call creates a kit called AirPy3XXX with all the compilers, the CMake tool, the CMake generator, and the CMake configuration defined. So it provides most of the kit definition. So let's look at what the script does in a bit more detail. So, as mentioned, the config option takes the environment setup script which you run when you want to enter the Qt SDK shell. So you enter the Qt SDK shell when you want to cross-build your Qt application against a certain SDK for a certain device. So the script sources this environment setup script like you would do on the command line, and so it knows all the environment variables like say CXX, CC, sysroot, and the native sysroot, and the target sysroot, and a lot more of the Yocto environment variables. Then the Qt Creator option and the name option are used to find the SDK tool, which is somewhere down in the installation tree of Qt Creator. So it's actually in the libexec Qt Creator directory. The SDK tool is completely undocumented, so I didn't find anything in the Qt documentation. But this is actually the thing that does the magic here. So you can use it. It has several options to create the definitions for the kit, for the Qt version, for the compilers, the CMake, for debuggers, and so on. So all the things, it creates all the things you see on the in the dialog: tools, options, kits, actually not devices. And finally, the SDK tool writes these definitions out as XML files, and so it writes files like profiles.xml for the kit definition, toolchain XML, and so on. For every tab page on the kits page, it writes an XML file. So now it's time to restart Qt Creator, and you see that Qt Creator auto-detected our kit, so the AirPy3XXX. You also see that most of the properties here are read-only, so we couldn't change the device type or the device, and we have to actually. And the same down here, so we couldn't change the CMake tool if we had to. The things down here, they look pretty much okay, although we don't know whether the CMake configuration is okay, and we cannot change that either. So what do? We simply clone the auto-detected kit, and then we can change the settings. So then it looks like this. So I just cloned it and gave it a new name, AirPy3 Qt15.1. And the only thing we have to change actually is the device type. It's the generic Linux device, and the device name, which is the Pi3B, which we defined earlier. The sysroot is okay. That is actually the target sysroot, where all the libraries and so on for the device are located. The compilers are also okay. it's the cross compilers for compiling to the ARM processor. The debugger, well, it should be okay as well. And then the Qt version is set to none. That may be a bit surprising. So actually, the Qt version is defined by the path to QMake. And as we are using CMake here, we don't need QMake. So it doesn't make any sense to set the Qt version. That's all in the CMake configuration and the CMake toolchain file. Now we have a make spec that looks fine. That's just for all Linux images built with Yocto. It's pretty much the same all the time. And then at the end we see here the CMake stuff, so CMake tool, CMake generator and configuration. So let's have a closer look at these three things. So we actually have or can have multiple CMake versions. So for example here my setup has CMake coming from the AirPi3 kit, which is version 3.15. Then I have the system CMake located at user bin, that's a 3.10. And finally, at some point I had installed a very new or fairly new CMake in user local bin, that's a 3.17.2. And as I said earlier, it's good to use the latest CMake versions and the latest Qt Creator. So you should use CMake 3.14 or newer and Qt Creator version 4.11 or newer, which we actually do here. And that's important because then installation and deployment just works out of the box. So the install commands in the CMake lists files just work. If your CMake is older or your Qt Creator is older, then the install commands don't work, and you have to write your own Qt Creator deployment.txt file, or you have to write some commands which puts in the CMake list files, which puts together this file. It's doable, but it's not nice. So we actually here in this example, we will choose the very latest CMake version 3.17. The CMake generator should be Unix make files, and the extra generator should be set to none. So make sure that it looks like that. I've never got the Ninja generating working so far. Maybe it's because, it could be because the Yocto version is too old or so, or it has some problems to work with Yocto build images. I don't know. Now comes the most important piece of information. It's the CMake configuration. So first I had to abbreviate this super long directory path as just P, so that the variables down here, the CMake variables down here, fit well roughly on a line. So you see it doesn't even fit then. So it's just huge paths. That's Yocto. So the paths are very deep. Good, so you have to define, or in the CMake configuration has to define 4 variables. It's the CXX compiler, the C compiler, where the make program can be found, and the toolchain file. So the first 3 are important to so that that when you run CMake, that it passes the compiler detection tests. If one of them is wrong, it won't work. And actually, in older versions, in older Yocto and Qt Creator versions, the CMake make program was the thing that was always missing, or that people tended to forget. And then the compiler detection test didn't work, and you could spend a lot of time to figure out why. That is the culprit here, the CMake make program. The final thing is the CMake toolchain file, and this actually maps the environment variables from Yocto, or from Open Embedded. Actually, it's these OE core variables starting with OE core or OE something. So it's variables like the sysroot, or also the compilers, of course, and some other variables which are needed for cross builds. And they are actually they are pulled from the environment which the script sourced before, and then assigned to CMake variables, and that's what the CMake toolchain file does. So the good thing is that our script creates a correct CMake configuration. So, and believe me, I've spent hours and days to get this configuration correct, and so the script really does a fantastic job here in saving us a lot of time. If you ever get in the situation where you have to write a CMake configuration by hand, that's the 4 variables you have to set, and then you're good to go. So now, home stretch. We specify the build, deploy and run settings, and can then finally run the application. Let's start with the build settings. The good thing about the build settings is that they are created automatically by Qt Creator. So we don't have to do anything. Actually, Qt Creator generates these CMake variable settings from the 4 variables we specified in the CMake configuration earlier. So we see the CMake compilers here, the install prefix, the make program, the sysroot, and a lot more. That's all done by Qt Creator for us. If the 4 variables in the CMake configuration are correct, or the CMake configuration is correct, then these settings here are correct as well. If Qt Creator comes up with some error messages passing the CMake configuration, and it will tell you here, then we have to go back to the 4 CMake variables in the CMake configuration and fix them. Maybe we have to add another variable. That can happen from time to time. We need only one build step, the step for cross-building all the targets with up to 16 processes in parallel. We must not specify an install target here. That's done. The installation is done by the run settings. If we specified an install target here, Qt Creator would try to install our application in user local bin, and it would fail because we do not have permissions to write there as a normal user. The deployment settings specify the deploy steps Qt Creator takes to get our application running on the device. The first deploy step, is to install our application into a temporary host directory. So this step, simply called CMake with the install target, and installs the application in this install root directory. It's some randomly generated directory name. and so it's installed there under this install root, and then user local bin Qt radio. And you actually see in this table up here, you see the mapping from the locally installed files to the remote directories on the where they will be installed on the device. It's a good idea to tick this box here so that the install step cleans the install root first before it installs the new application or new files in there. Otherwise you can get a mix of old and new things which might not work. The next step is to check for free disk space. So Qt Curator checks whether there is enough disk space available to install all the given files on the device. Our application has a size of less than 1 megabyte, so 5 megabyte are more than enough here. And yeah, well, if you have bigger applications, or you have applications plus Qt libraries plus some other files to install, then you have to increase the size here. The third step is to kill the currently running application. So what Qt Curator does here is basically something like a kill all command with the executable name. If you have to kill multiple applications, then you replace this kill command by a custom remote command. And the custom remote command would just call kill all with a regular expression specifying the applications to kill. And don't forget to add a pipe true at the end of the kill all command, because if kill all fails because there is no application to kill, well, it will fail, and then the deployment will stop at that point, which is not what you want. The final step copies the locally installed files, so for us it's just the application, to the device using rsync. So that's the deployment, and now the last thing is the run settings. So the run configuration is offered, or Qt Curator offers a couple of run configurations, one for each application executable. We only have one, so it's Qt Radio on Pi 3B, which is the device we defined earlier. We want to specify our own executables, so we tick this box here so that we can enter our executable name here, which is user local bin Qt Radio. We also specify some command line arguments. Here it's -platform eglfs, because we run the internet radio over eglfs and not over, say, Wayland or X11, which would be a bit of an overkill for a single application. One thing I noticed here, if you tab complete names, then Qt Curator will only see the partial name up to the completion and will try to run that. So you make sure, if you tab completes things here, hit return explicitly afterwards, or click in some other field, and then it's really submitted. Now we have reached the scary moment where our dreams come true or where they shatter. So we hit the run button or press Ctrl R and see what happens. So in the compile output pane, we see that Qt Creator successfully built our target application. It installed it into the install root under user local bin. It's all working. Then it checks whether there's enough free space on the device, which there is. It not only tries to kill the application, but it actually kills it. And then it copies the new application binary to the device using rsync. And our dreams come true. It starts the application on the device, so user local bin Qt Radio with the arguments we specified, and we see some messages from our application. So let us enjoy our hard work again here and see what we have achieved. So we started out with this setup. So the background color here, the yellow background color was wrong. We changed the color in the code from yellow to red. Then we hit Ctrl R to deploy the application onto the device. We see the steps here, and which involves killing the application, hence the screen turns black. And we copy the new application over there. And then Qt Creator runs the application, and we see that our change was successful. We have a red background here. So we can now develop on an embedded device in the very same way as on the desktop. So we just edit our code, hit Ctrl R, then Qt Creator does a lot of things behind the scenes for us, and the application runs directly on our device, and we can get immediate feedback of how the application behaves on the device. So that brings me to the end of my talk. Thank you for your attention. I hope to meet you in person in Florence next year. And in the meantime, stay away from Corona, stay safe. And I'm now available for questions. Thank you very much.
All right, everyone, welcome back. We are now able to do the Q&A session. So let's go ahead and bring Burkhard on. Hello.
Hi again. I'm still here.
Yeah, that's awesome. So again, thanks so much for that video. Yes, virtually this year we have to do it, but hopefully in person next year.
Definitely.
So I see we have a question in the Q&A, and before we start with that, I just wanted to ask if you had anything else you wanted to say, either about the talk or about your participation in Q today.
Me? Okay. Yeah. Well, the talk is actually directly taken from my daily work. So over the last I think weeks, months, and I ran into trouble with CMake and Qt Creator quite often. Cost me a lot of time to get things working, and it was only actually for this talk when I discovered the configure Qt Creator shell script. Which is a real time saver. So doing all that by hand, figuring out which CMake variables you have to set, how to start Qt Creator in the with the right environment setup, and so on, that's really painful. And that script makes it a lot easier. And that was when I sat down and created this presentation. So it was thought to be slightly different, and then I found that and thought, well, that fits very nicely.
Excellent. Well, thank you for sharing with us what you've learned. And
yeah, you always learn when you do talks.
Of course, yeah. Learning by teaching, for sure. So our question here by Josef says, can you please explain how to transfer files during deployment using the rsync step?
Well, most do you want to do that from the command line? So you would well, when you do it with Qt Curator, it's what Qt Curator gives you there. So it's the rsync -AV, I think, is the option, and then that works. I think I had one case where it didn't work for whatever reasons, and then I had to pass some other arguments, and you can specify that in Qt Curator. If you want to do it on the command line, you can do it with exactly the same command. So actually, the nice thing, you can do every deploy step you can do on the command line, and if you look at the output from Qt Curator, you see what command you should execute.
Great.
I'm not sure whether that answers your question, Yusuf. Okay, good.
Okay.
Thank you.
Yeah, thank you. All right. So I believe there are not any other questions unless, nope, that was it. So if anyone else has other questions that they can think of, where can they find you?
Well, my email address was on the last slide.
Mm-hmm. So they can email you for that.
You can feel free to email me. You can reach me on Twitter as Witty Elk. Yeah, I've lived in Norway, so there are a lot of elks running around. No, it's a nickname I got from running around in the forest when I was a teenager. So
lovely.
Stuck. And yeah, so you can go to my website, embeddeduse.com. So yeah, there are plenty ways to reach me, or read my newsletter. I think Andrea is one of the newsletter readers. So there are plenty of ways to get in contact with me. And all this stuff, which, well, I think at the moment it's not on GitHub, but you will find all the stuff to build the Linux image for the Raspberry Pi 3. That's on my website, and it's also on GitHub. So you could actually do these things live.
Fantastic. We appreciate that. All right. Well, then I guess we can wrap it up a little bit early. So I want to thank all of our participants, and of course, thank you for your time and your participation in Qt as well.
My pleasure, and thank you very much. And as I said, stay safe, stay away from Corona. I think we are all in lockdown now.
Yep.
And yeah, that's how it is, but we'll get through it. And next year we'll see us in Florence.
Yes, crossing our fingers.
Drink good wine and eat very well. So that's what I'm actually missing. So it's doing that virtually is nice, but
not the same. Yeah.
Talking to people, enjoying the good food, and la dolce vita. That's what you can't do online. So thanks a lot.
Of course. Well, we're happy to have you. And yes, we're crossing our fingers for an in-person event next year.
Germans press their thumbs. So.
Oh, I like that. I'll have to start doing that from now on. All right. Well, thank you again. And I hope you have a good night and see you in the next edition.
And you.
Thanks.
Bye-bye.
Bye. All right, everyone. So if you enjoyed this talk, I'd like to just kindly remind you that you can rate it actually on the agenda page of Bizzabo. So please do that. We always appreciate feedback, whether it is good or bad. As you all know, feedback is very important. So I'm concluding by saying our last talk of the day is actually the keynote, which is Qt Containers and Algorithms by Thiago Masciera, and that is at 6 p.m. So in about 20 minutes or so, we'll see you there. All right, take care, everyone. Bye. Bye-bye.